Hello, welcome back. I'm Mr. Eicher. This is part 2 of a video, chapter 7, section 1, and we're going to be focusing on dividing rational expressions and simplifying complex fractions. So let's take a look. Let's review back in the day when you had fractions that you were dividing. Now, to divide these with a calculator is probably pretty easy, but it'll be really helpful if you understand the process of division with numbers so that when we get to division with rational expressions, they're not completely out of this world for you. So there's a phrase that I didn't learn, but students taught it to me. My teachers didn't, but my students taught me this. It was something like keep, switch, flip. I think that's what it was, which is you keep the first fraction, 4/7, you switch the division sign to multiply, so that's multiply now, and then you flip the second fraction. And now it's a multiplication problem, and we can solve that the ways that we were solving in the previous video. You could either multiply across, you could multiply these, and then simplify, or you could divide out common factors like 14 and 7, that'd be a 1 and a 2. 4 divided by 24 is a 6 and a 1, so we'd have 2/6, which is really 1/3. So 4/7 divided by 24 14ths equals 1/3. And that idea of keep, switch, flip, we're going to use basically on the next couple questions here. And I have it written out here: to divide two rational expressions, multiply by the reciprocal of the divisor, which is the denominator. So the switching part, you're switching to multiplication, and the flipping part is the reciprocal of the second fraction, which ends up being the denominator if you were to write it as a complex fraction. So we can rewrite number 11 as keep the first one, so that would be 3/5d, change the sign or switch the sign to multiply, and then flip the fraction 15df over -9. And then from there you could either multiply across, so you can multiply these and then simplify, or you could divide out common factors like 3 and 9, 15 and 5 you could divide, d and d you could divide. So either way, maybe let's try the multiply across method. You would have one fraction, 3 times 15 is 45, df. 9 times 5 is -45, d. And then we can divide the 45s and the d's. So it looks like we have left f over -1, which we would call negative f, is how all that simplifies. On the next question, number 12, I'll get you started on it, but you'll finish it as a try this. I just want to point out that you'll need to factor several of these. You need to factor this top one and this denominator. And this has a greatest common factor, 3r plus 3. So if I read it like this, I'll just get you started a little bit. You need to factor that numerator. I'll let you figure out where to go from there. But when you multiply, I'll change that to multiply now, you're going to have r minus 2 in the denominator, and you're going to have 3 times something in that second numerator. So taking a 3 as a greatest common factor out. I'd like to see if you can finish that as a try this. If you'd like to pause the video and finish it now to save your time later, that would be excellent. Okay, our last topic is simplifying complex fractions. Complex fraction is simply a fraction within a fraction. So what I'd recommend doing with these, we'll look at number 13, it's important that you realize you have a fraction in the numerator divided by a fraction in the denominator. This divide bar is really important, that you realize that divide bar is separating the numerator from the denominator. So that's our divide bar. So if we rewrite this like the ones we were just doing, we would have m cubed over 3n divided by negative m to the fourth divided by 9n squared. Now this looks really similar to the ones we were just doing up here, like number 11 or number 12. So we can keep the first, m cubed over 3n, multiply now by the reciprocal 9n squared over negative m to the fourth. And then you can divide out common factors. So 9 divides with 3, that would be a 3 in the numerator. M cubed is going to divide with m to the fourth, and you're left with m to the first. And n squared is going to divide with n to leave you n to the first. So again, kind of the negative way of dividing like this is it's easy to lose stuff in the process. So let's see if I get everything. We have a 3, an n, we have a negative m in the denominator. So we would type that as negative 3n over m, like that. I'd like you to try number 14 as a try this. Remember, this is the main division bar right there. So if you'd like to pause the video and try that, that would be fantastic. The last one I'd like to walk through with you is number 15. Number 15 is a complex fraction, and here's the main fraction bar right here. This is the divide. But also we're going to need to factor this. We need to factor this difference of two squares. And we also need to factor this trinomial. So let's rewrite it as 2y over, need to factor that first one, divided by 3 over, and then we need to factor that next one. There we go. So y squared minus 4, that would be y minus 2y plus 2. And y squared minus 4y plus 4 would be y times y is y squared. To get to 4, we could use 2 and 2, and they both would be negative. And then we could rewrite this as 2y over y minus 2y plus 2 times, switching the sign here, times the reciprocal y minus 2 y minus 2 over 3. And then we can divide common factors, and we can divide diagonally. So we have a y minus 2 and a y minus 2. And that actually looks like it's it. This one is not identical, y plus 2 is not identical to y minus 2, so you can't divide those. This singular y here is not the same as y plus 2, so you can't divide those. And this 2 is a coefficient on y, but this 2 is adding to y, so you can't divide those 2's. So really it looks like our final answer is going to be 2y times y minus 2 over 3 times y plus 2. This would be our final answer. If you multiplied it all out, it would look like this, 3y plus 6. But typically we're okay with the answer typed like that, or written like that. Thanks for watching this video. I hope it was helpful for you. Thanks for your persistence this year, and I hope that you succeed and do well in this chapter. Please reach out to me or to whoever your teacher is if you have any questions. Have a great day.